Thanks, Chris. We're actually less than 6 minutes away from today's 535-second test. That's actually about a 9-minute test. When the SLS is in flight, the engine will operate for about 480 seconds or close to 8 minutes. But Gary, what I really want to know about is, why do we test engines?
We test because we love to hear the shake, rattle, and roll, and look at all that awesome power strapped into the test stand. No, but in all seriousness, we test because we want to verify that engine performs as designed. If there's going to be a problem with the engine, we want to catch it on the test stand. We don't want to have a problem during flight that could jeopardize our crew or cargo.
Absolutely. You know, the RS-25 is a liquid-fueled engine. It's liquid oxygen and liquid hydrogen, to be exact. How much liquid oxygen and liquid hydrogen will we use in today's test?
During today's test, we'll burn about 150,000 gallons of liquid hydrogen and 60,000 gallons of liquid oxygen. That's over 200,000 gallons total propellant. That's enough to fill up a 10 of your average-sized swimming pools.
Wow. Can you tell us a little bit about today, what's happening to get ready for today's test? Maybe what's happening behind the scenes in the Test Control Center, or maybe even what time you all got started today?
Yeah, well, test day usually starts about 6 a.m. There's hundreds of instruments that we're going to be looking at for today's test. Pressures and temperatures, speed probes, strain gauges. So we want to verify that all that instrumentation is working properly before we even get started into test day. And so after all the electrical engineers and technicians have checked out all this key data system, the test conductor will call the group together and have a pre-test briefing in the morning. He'll go over the test procedure, any special operations. It gives a chance to verify all open constraints are closed before test, and gives a chance for anybody to speak up if they have any reasons not to go into test. So shortly after that, the team of technicians and engineers will dispatch. They'll go out to the test facility and get the test stand ready, start to regulate gas pressures that we'll need to support the test. Some folks will go out to the barge docks and get the propellant barges ready in case we need to transfer fuel. Another team will go to the Test Control Center, and they'll start to set up the data and control systems. One of the things that we do after we get the new software loaded onto the engine computer is to power on the engine and go through a series of purge sequences. The reason we do that is because we don't want to have any moisture inside that engine. Remember, these propellants are really, really cold, and we don't want anything to turn into ice or solid in there. So we purge the hydrogen system very well with gaseous helium, because that's the only gas we have that won't turn into a solid at that cold of a temperature. And we purge out the liquid oxygen system with nitrogen. And once all that's
how many
done,
purge sequences do you go through before a test?
There's 3 or 4 purge cycles that we usually run through. After that, we've got the engine preconditioned. It's ready to have some liquid oxygen and liquid hydrogen drop down. So we drain some of the propellants out of the tanks. We open up the facility valves, and we begin to chill the engine down. It takes a couple of hours to get all that metal cold. We've got to get liquid temperatures in that engine. So we do a slow, methodical process. We start with liquid oxygen. Once the temperatures are stable, we'll send the technicians out, do some inspections, make sure everything's working good on the engine, and we repeat that process with the liquid hydrogen system. After that, really we bring up the water pressure, do some final checks, and send the test crew back to the Test Control Center at a safe distance. Deflector water pressure is increased. The exit ignite torches are activated, and when we get closer inside the 1 minute, maybe where we're at now, the test conductor is doing a final polling of the management team and the test team to verify that everybody's a go for test. We have limited time on our super high-speed video recording systems and data recording systems, so those are usually the last 2 systems that are turned on. So if all the conditions are met, the test conductor will have what's called a prep complete indication on the screen, and at that point in time he can initiate the auto sequence start and begin the test.
So there's actually a button you push. Is it a red button?
Well, it's like it's a green button.
Okay.
There's a red button, but that's in case there's an emergency shutdown, and we don't ever want to hit the red button.
Absolutely. Well, we're kind of in standby right now, waiting for the 1 minute notification for the RS-25 test. Today's test will be 535 seconds. sounds like we did get the 1 minute notification. So, Gary, maybe what happened just right now in this time, right here before the test?
Well, yes, they are probably just finishing that bleed sequence. Like we said earlier, we've got to get those inlet temperatures and pressures just right, so they're probably fine-tuning the control valves to make sure we've got the right temperatures, conditions at the engine inlet and inside the engine, and also getting the tank pressure set.
For the RS-25 engine test here at Stennis Space Center. Sounds like auto sequence has started. RS-25 engine has concluded. That certainly was exciting. You could actually feel the power from it. Gary, I'm curious, what's happening right now immediately following the test, and ultimately, what do you have to do to get ready for that next test?
Well, wow, there's probably a few people in the control center high-fiving, because that was a very, very successful test, and you got to see an awesome display of the power. And can you imagine 4 of those RS-25s all going at the same time? But yeah, so what will happen right now is the engine will go into post-test shutdown mode, and we'll do some securing of the facility systems. We'll evacuate the propellants out and get the stand in a safe condition. And then shortly thereafter, we'll dispatch some engineers and technicians out there to do final inspections of the test stand. And tonight, the engine engineers will go out there and do some inspections on the engines. We'll turn on some drying purges and let those purges run overnight and get the engine all dried out after test. And another thing is people will start looking at the data. You know, we've got, like I said, all those hundreds of measurements. So engineers will be poring over the data from today's test to look and see if all the objectives were met.
And that's the part you guys really like.
That's right. Lots of plots and graphs and numbers for the engineers to look at. And usually what happens is a couple of days later, we'll have a full-blown formal data review, and we'll talk about the objectives and start planning the next test. If we didn't meet an objective into today's test, we can roll it over into the next test. And so that's kind of the process that we go through there.
Well, your engineers and technicians certainly did a great job today. It was a great show. We're going to go back out to NASA Edge to get a reaction from the crowd out there. It looked like a whole lot of steam.
I tell you what, Kim, I'm speechless right now because, you know, we've seen shuttle launches. We've seen launches at Vandenberg, from Kennedy, from Wallops. I tell you what, this was unlike anything I've seen before.
And you know, Kim, to me, the most amazing thing is most of the time when you see a launch, the spacecraft is moving away from you. And here you feel the impact sustained. And that must be what it's like for the astronauts. And I know because of my wife and other intellectual deficiencies, I'll never be an astronaut. But this is as close as you can come to feeling what they feel on a launch. It's pretty impressive.
It was just sheer raw power for 8.5 minutes. I mean, just to see all that steam coming out and the crowds with the excitement taking video and pictures, and they're all fighting for jockeying positions to get that ultimate picture.
My chest cavity was kind of rumbling.
It was unbelievable.
Absolutely.
And Franklin, over there in the A2 test stand, I can only imagine what it was like from your end.
It was a beautiful sight, guys. The power, as you said, you could feel it from all the way over here, and you were just a little bit closer than we were, so I know you could definitely feel it. And after the test was over, I actually was over here viewing it with Walt Janowski from Aerojet Rocketdyne. He smiled and he was happy with the results, so I assume it was a very successful test. Guys, back to you.
Now, Franklin, because joining us now is Steve Wofford, who is the SLS Engines Manager. And Steve, what are the initial results?
Initial results are great. We ran full duration, 535 seconds. We met our test objectives. Didn't note any anomalies at this time, so now we get the fun part of going through the data.
Well, that's awesome. I tell you, and you can feel the excitement here with the crowd. And I mean, already here you feel instant victory. You know, it's total success. But tell us, you get the data. How long before you actually know that the data, with the data that you get, that the test has been a success?
Okay, so we know that the test has been pretty successful right now. So we had one of our primary test objectives today was to demonstrate the 4.5-minute chill cycle on the fuel side, which is a flight-like condition for SLS. We hit that, we made that, so I'm really, really happy about that. It's a very much shorter chill cycle than we had in shuttle, so we knew the engine could do it, but we demonstrated it today. So the other test objectives, we know we were successful. We'll spend a week going through the data to make sure there's no other anomalies that we've missed.
Now, on a test like this, I think you probably just answered my question. Are you going to use this data on today's test for the next development test?
Absolutely. So we learn every time we go. So we'll take the lessons learned and the data from this test, fold them into the test objectives for next time.
And I just got one final question. Steve, you're out here, you see the crowd. I mean, we're on our journey to Mars. You see the crowd all pumped up. What was your feeling like?
My feeling was elation, just like you guys, right? It's a great day for NASA. It's a great day for the SLS program. It's a great day for our Liquid Engines office and Aerojet Rocketdyne team. So it's good to be here.
So it's a great day all around. I mean, apart from intense temperatures, which the engine did a far greater job of handling temperature than we ever will. It's just an awesome success, and we're just glad to be a part of it.
I tell you what, Kim and Gary, we had a success from our end. I'm sure you had a great time viewing it from your end. Take it back. It's back to you.
All right. Thank you. you so much. Today's test of the SLS RS-25 engine is a major milestone on our journey back into space and on to Mars. It's been a pleasure here watching the test with Gary Benton to get this insider's look of what goes on behind the test scenes. We want to thank you for joining us today for our live coverage of the Space Launch System RS-25 engine test here at NASA's John C. Stennis Space Center in South Mississippi. We'll now conclude today's broadcast. To follow the progress of NASA's Space Launch System, you can follow us on Twitter at NASA_SLS and Facebook.com/NASASLS, or visit us on the web at www.nasa.gov/SLS. And for all the latest news from NASA as we reach for new heights to reveal the unknown for the benefit of all humanity, visit www.nasa.gov.